All right, so we're looking to understand how transformations will apply to different graphs. And there's going to be how they change the graphs of the functions. So, starting here in example 1, they want me to graph the absolute value function, right? So, the absolute value is the distance a number is away from 0. So, for instance, -4 is 4 units away from 0. -2 is 2 units away from 0. 0 is definitely 0 units away from 0. 2 is 2 units away from 0. And 4 is 4 units away from 0. Now, what we are creating is a situation that looks like this. Okay. What is the domain of this? Oh, they only want me to, I did something wrong here, folks. They only want me to use from -4 to 4. So I was not following the directions. And the range goes from 0 to 4, including both ends. What happens when you multiply the y values by 2? Let me type that out. Multiply y values by 2. Yeah, let's do this. Shrink this down. So, obviously, we would have 8 and 4 and 0 and 4 and 8. So the original core x value was -4, but the new y value is 8. And so we have original x, new y 4. Original x, new y value 5. Original x, new y value 4. Original x, new y value 8. What's that going to look like? This is called a vertical stretch. I'm going to use the word increases. So the domain, still -4 to 4. But we multiplied those y's by 2, so that changed the range by stretching it. Okay, now we're talking about shrinking. All right, now, this looks like you are multiplying the x's by 2. I do see how that appears. But what you're going to see here is that, well, actually, and they're only doing they're actually doing what's called a horizontal shrink. Okay, So starting with -2, this is just on your plain old original, so that's 2 units away from the origin. -1 is 1 unit away from the origin, 0 is 0 units away from the origin, 1 is 1, 2 is 2. Okay? Now, they asked me to do the domain from -4 to 4, that's why I stretched it out farther. Okay, now, when you do what they are showing you, doubling the x's, okay, now I'm plugging in -4, and I get 4. Now I'm plugging in -2, I get 2. Plugging in 0, 2, 4. Okay, so what does this look like on my picture? Sorry for the beep in the background. My coordinate is -2, right? That's the original x. And now I've got a new y value of 4. So that's -2, 4. And the next one, -1, 2. -1, 2. And of course, 0, 0. That one didn't change. 1, 2, and 2, 4. Which, if I extend this out, will continue to here. Now, wait a sec. That almost looks the same as the last one. I'll have to look at that in a second here. But the domain, -4 to 4, the range 0 to 8. Dang, that looks like the last one. Well, what's the difference? Well, I'm gonna show you what the difference is. The final image looks the same. These points got moved in. They got moved in. There was a horizontal shrink involved. These points got moved up, stretched up. End result, exactly the same thing. So, some of these stretches and shrinks can produce the same effect on something that is symmetric to the y-axis, touches 0, 0, that kind of thing. So a transformation that decreases the distance between the points of a graph in a given line by the same factor is called a shrink. It is weird that a vertical stretch and a horizontal shrink can provide the same effect, same looking effect. Okay, so how do I know when a vertical is a stretch? When the a value, that's the amount that we're multiplying by, when the a value is bigger than 1, we have a stretch. When it's smaller than 1, we have a shrink. That reverses itself when you get to the horizontal. So when a is bigger than 1, you actually have a shrink. When a is less than 1, you have a stretch in the horizontal direction. Based on the way they have written these instructions. I know this over here kind of gets confusing, right? Because you're thinking, well, why when you multiply by something that's smaller than 1 does it get bigger? It has to do with how it's affecting what's going into the function. We'll talk more later. Okay, so first two graphs here have two changes. The third graph has 3 changes. So, you know, we're going to work this out and show you what to do here. So we're going to always start with just the order of operations, right? Order of operations, multiplication comes before addition in the order of operations. So we're going to do the reflecting before we do the shifting. I'll come back to you in a minute. All right, so let's do the reflection first. Now, since this is on the outside, that's changing the y value, right? It's that multiplier of -1 is on the outside. So that means it's changing the y value. So if you're changing the y value, just remember what we talked about, how if you're changing the y value, that means you'd be going across the x-axis, right? Down here to a negative y value. You got a positive y value, and you're multiplying just the y value only. So that means this point, I'm going to jump down to here, and then I'm going to have this point here, and then another point here. So far, oops, make those up a little bit better. So far, here to here to here. Okay, and then there's a point way up there at 1. Okay, so right here. Okay, so that's what we got first, right? That's your reflection. All right, but now we want to do this, right? This is left 2. So the whole graph goes over what is going on. Hold on a brief moment. Okay, I'm back. So the purple one is the final answer to this question. So I can take the other ones away. So reflect first, shift second. Okay, now, in this particular one, we have, once again, it's on the outside. So that is a vertical shrink. And I'm not writing very small, am I? And then, of course, this is on the outside, and it matches our common sense. So that's up 3. So vertical shrink by 1/2. So let's start with that. Do that in the red. So that means every point gets half the distance of the y's. So each one of those y's is halfway to the x-axis. So there we've got our vertical shrinking going on. And now we're going to go up 3 with that. So every point just slides up 3. We got one right there. One right there. Oh, come on. I don't want to add an image. And then that one goes up 3. 1, 2, 3. And then that one goes up 1, 2, 3. So split it up. So the red one is not part of your final answer. Well, we did the shrink first, which brought all the values closer to the x-axis, since it was a vertical shrink. And then we moved the whole graph up 3. Okay, we've got several things going on here. We got 3 things going on here. Now, 2 of those are on the inside with the x. So that would be a horizontal stretch because it's a 2, which is bigger than 1. We're also multiplying the x by -1, and when we do that, remember, we're jumping across the y-axis, so there's going to be a reflection across the y-axis. And then there's going to be the last thing in our list is this one over here, and that would be down 4. But we're going to do the multiplying part first. Okay? So, we'll start with the horizontal stretch by 2. Horizontal stretch by 2. So, this point is going to jump off the graph. I mean, it's actually going to go all the way over there because it's going to. And then, of course, that point will be right here. Sorry, this point moves to there. So, there's your horizontal stretch. You pulled it away from the y-axis on both sides. But now we have to reflect that across the y-axis. Okay? So the point is going to, so you've got, this point's going to come way over here, right? Because it's got to go 1 unit off the graph. And then I'm going to have a point there, there, and a point here. So there's your reflection. Let me get rid of some of these lines. The orange one got reflected. So first I stretched it, then I reflected it. Those are both based on multiplication. So it makes sense how I do that first. And then lastly, we're going down 4 with the whole graph. So every one of those points can, you know what? I should just see if I can change it to circle. Down 4, boom. Come down 4, boom. Down 4, boom. And come down 4. I think I went a little bit too far on that one, but you get the idea. It's nice if I can use these lines. And then, of course, the red one is not part of the final answer. So that's what happened. Did a stretch. Now, could I do the reflection first and then do the stretch because those are both multiplication? The answer is yes, you could. But you want to save that the shifting part for the very end because that is based on addition. All right, so on part A here, they're asking me what transformations result. So you're starting the original function. Here, I'll highlight it in blue. The original function, whoops, scribble. The original function is, the parabola at the beginning. And then they have like a stair step, so the first thing they did was, you can see on the inside, they did a horizontal stretch. I can't spell. By 3. So took all these values and stretched them way out like this. And then after that, what's on the outside, right? That's changing the y value. So that's a reflection across the x-axis, which is why it flipped down. So that completely makes sense. horizontal stretch, and then reflection across y-axis. Nope, x-axis. Gotta change that. Come over to the next one. Once again, the blue one is what we start with, y equals x squared. And there's no multiplication going on here, so I don't have to worry about doing that before the shifting. I can see that they chose to go right 4 first. That's how you got the green one. And then they chose to go up 5 next. And that's how they got G, the final graph. What transformations are applied to the graph? Is there a graph drawn? I wonder if I accidentally attached it to the next slide. Let me check. Nope, they just wanted a description. So this is on the outside, so this is a vertical shrink by 1/2. And this is on the inside, which goes against your common sense, so that's left 3. This is on the outside, so that's a negative y. That's a negative 1 times y. So that means we're doing a reflection across x-axis. This is on the outside, which matches our common sense, so that is shifted up 2. So those are the kinds of descriptions I want to see. A reflection across x-axis and up 2 for that one. All right. A scenic train ride makes trips on an old mining line. Graph shows the distance in kilometers of the train from the station X minutes after the ride begins. What equation represents the distance from the station as a function of time? So what kind of stretch did they do? Well, first of all, you can tell that this is upside down. So I know that that means that A is negative. Now, what are the slopes of the lines? Because that would be kind of helpful. Let's see if I go down 15 and over. That would be down 15 and right 15. So down 15, right 15. Well, that's a slope of negative 1. So we just found our A value to be negative 1. What's the domain of that function? Well, it looks like it's from 0 to 30. How would the graph and its equation be affected if the train traveled twice as far in the same amount of time? Well, twice as far? Wouldn't that mean speed that the lines would be twice as steep? Which obviously I'm talking about the slope of the lines. The A value would be doubled. The slopes of the lines would have to be doubled, because the bottom's not changing, but the top would be. And I think that's the conclusion of the notes there for this particular section.